All right, we are looking at 1A.3 now. Our 1A.3 mastery learning objective is I can simplify an expression by using the product and quotient rules to multiply and divide with exponent. So we know what expressions are. We don't know what our product and quotient rules are. We should know what multiply means. We should know what divide means, and we know what exponents are. So most of these words we know, right? So we're simplifying an expression just like we did in 1A.2, combining things, right? Putting them together. If you don't know the word product or quotient, product is just your answer that you get from multiplying. Quotient is your answer you get from dividing. So we're going to learn about those rules today, and when we multiply and divide, when we have exponents. Okay? All right, so let's look at what operations with variables are. When you add, right, the number of x's is the coefficient. So all of these have an addition sign. I'm going to count them up. 1, 2, 3, 4, 5. That 5 becomes my coefficient when we add. When we multiply, the number of x's is the exponent. So again, I have 5 x's here, but this is different. Okay? Again, multiplying and addition are two different things, so I have to express my answer differently. And that's the difference. It's either the coefficient or the exponent. Now, we're going to look at our next set of things. I'm going to simplify my expression by first expanding it. So what does that mean? I'm starting with x squared. Remember, this exponent, just like up here, tells me how many times it got multiplied. So x times x. Now that's being multiplied by 8 x's. 6, 8. I think that's 8. 1, 2. Yes, 8. Okay. So now how can I write this? Well, in total, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. So x squared times x to the 8th is just x to the 10th. Looking at number 2, slightly different because now we have these coefficients in front. So I'm just going to write 2 times z. I have 3 z's. Then I have 2 z's. Okay? And that's all it is for expanding it. Well, the first thing I can actually do 2 times 4. I know numbers, right? 2 times 4 is 8. Z. I have 5 z's being multiplied, so it goes as my exponent. So this becomes 8z to the 5th. Looking at number 3, I'm going to do the same thing. I have x times y times y times y. Then I have 3 more x's. And then I have 4 more y's. So when I rewrite it, I have a total of 5 x's being multiplied and 7 y's being multiplied. Some of you might have started catching on to what this rule is that we are kind of figuring out. It is the product rule, which says when I multiply with 2 exponents, I can add those bases together, or I can add those exponents together, right? I got 10 from 2 and 8. 2 plus 8 is 10. 3 plus 2 is 5. That's only if the exponents are the same, or the bases are the same. I had to do my x's. 2 plus 3 is 5. And then my y's. 3 plus 4 is 7. Okay? Why does this rule help us? Why can't we just write it out forever? First, it's faster. Second, when you don't have whole numbers, when we have fractions, I don't know how to write 2/3 of an x. Okay? So it really helps us with these fractions when we no longer can write it out. That rule still holds. I'm just going to be multiplying. I'm just going to be adding those exponents. So we take our base. All of these have the same base of x. And I'm going to write that base down. And then I'm simply adding my exponents. 2/3 2/3 plus 4/3 plus 1/3. With adding fractions, if they all have the same number on bottom, remember you're just adding the numbers on top. 2 plus 4 plus 1 is 7/3. If you struggle with adding fractions, get a calculator. You can use a calculator on everything, okay? So don't be afraid to use your calculator for those things that you struggle with, okay? And that's it. Look at our next one. Both of these are y. So I have y to the 1/2 plus 1/2, right? I'm adding both of these. Okay. I am going to use a calculator starting now just to make it a little easier. So I have 1/2, so I'm going to write my calculator as 1 divided by 2 plus 1 divided by 2. That easy. And I get 1. So this is just y to the first, but we're not actually going to write it like that. We're just going to write y, okay? So you do not need to write an exponent of 1. Just like how we don't write a coefficient of 1, right? If I just write an x down, I know I have it once. I don't need to tell you that I'm having it once, okay? All right, looking at 6. Now this is a little different because I have two different variables, or two different bases. So this is, I'm going to start with my f. I'm adding the exponents for f. And then I'm just going to do the same thing with g. Now remember, we still have to remember there's technically a 1 there. And the 2/3. So now I have f 1/4 plus 5/4. So 1 divided by 4 plus 5 divided by 4 is 3/2. And then g, same thing, just add them. I'm going to stop looking at the calculator now. You guys kind of get the idea. Right, g to the 5/3. Don't ask me why I wrote my fractions two different ways. I'll sometimes do either. Doesn't matter to me whichever one you prefer. All right, looking at number 7. Now again, this is a little different because I have my coefficients. When you have coefficients, you just multiply them. Right? It's just like what we did up here. Right? The 2 and that 4 just kind of, it had nothing to do with how many z's there were. Okay? So I still need that 3, that 2, and that 4. Then I take my c's. Then I have the d's. So 3 times 2 times 4, we get 24. And again, use a calculator if need be. 2/5 plus 3/5 is 1. And then 1/2 plus 1/4 is 3/4. Now I'm going to rewrite this again because I don't like that there's a 1 variable there. Right? I'm just going to write 24c g to the 3/4. Okay, we don't write that variable or that exponent of 1. Oh, I can talk. All right, looking at 8. Same type of thing here. I need to pull out. I need to multiply those those coefficients. 3 times 2. Then I have a base of x for both of these. So I'm doing 4/5 plus 2/5. 3 times 2 is 6. And then I have x 4/5 plus 2/5 is 6/5. Now our last one for our product rule. Again, I have to multiply my numbers. I have a 2, a 9, and a 3. Right? Then I have an A here and an A here. So that's A to the first, right? And a second. And then I have B to the fourth. And there's no other base of B, so I'm not actually adding anything to it. So it just says B to the fourth. 2 times 9 times 3 is 54. A to the 1 plus 2 is 3. B to the fourth. Okay? And that is our product rule. All right, we're going to do a few, looking at the next page, we are also going to look at our quotient rule. So again, we're going to start by expanding. We look at number 1. I have 5 x's on top. And I have 2 x's on bottom. So then what happens? Well, this x and this x go away. Right? And I am left with just 3 x's in my numerator. Okay, I could put it over 1, but I do not have to. You don't have to have a denominator. Looking at our second one, right, I have 4 over 8 times 7 x's. 2, 3, 4, 5, 6, 7. Right? The x's again, it's easier. Right, that part. We can take away those 3. I'm left with 4 on the bottom. And then for here, I'm just going to divide. And again, I can use my calculator. What's 4 divided by 8? 1 over 2. Okay? So I know I have a 2 with 4 x's on the bottom. And you do always have to have a denominator. Okay, so that 1 does have to go up there. 1 over 2x to the 4th. Okay, looking at our last one, I have 2 x's and then 5 y's. On the bottom, I have 6 x's and 2 y's. Okay? I can only cross out things that are the same. This x and this x, this x and this x. I have no more x's, so those 4 x's have to stay there. This y and this y, this y and this y. So what do I have left? On top, I have 3 y's. On bottom, I have 4 x's. So again, some of you might have started noticing what the pattern was. How did I get 3 from 5 and 2? Well, 5 minus 2 is 3. How did I get a 4 from 3 and 7? Well, 7 minus 3 is 4. Same thing here. 6 minus 2 is 4. 5 minus 2 is 3. Now the weird thing is, how do you know where it goes? Wherever your larger exponent is, that's right. My larger exponent was on top, my larger exponent was on bottom. For x's on bottom, for y's, the larger one was on top. Okay? So when dividing two numbers with the same base, you subtract your exponents. Okay? So same thing, rule kind of thing applies with these coefficients. 2 divided by 2. And then where is that x going to go? Is it going to go on top or on bottom? The larger x is on bottom. Expand this. So I'm going to have the x on bottom, and I'm going to do 4 minus 2. So this one minus that one. Okay. So 2 divided by 2 is just 1. 4 minus 2 is 2. So 1 over 1x squared. You can also write that as just 1 over x squared. You don't need that coefficient of 1 on the bottom. You do still need a 1 on top. Looking at number 2. Again, We just have the 12 divided by 4. Where are my y's going to go? Well, 5 is bigger. Right, so they're going to go on top. 12 divided by 4 is 3. 5 minus 4, right, is just 1. So I can write that as just 3y. Okay. 2 more. This one has 2 different variables, so I have to decide where they're going to go. My x's are going to go on bottom. My y's are going to go on bottom, right, because 11 is bigger too. Now, something needs to go on top. You always need a numerator. So I'm just going to throw a 1 up there. Right, there's nothing up there, it's just 1. So I have 1 over 8 minus 6 is 2. 11 minus 2 is 9. Our last one, right? So I have 3 over 15, and then I have x's, my larger exponents on bottom. And then I have y's, my larger exponent is in the numerator. And remember, that's a 1. And so don't forget your 1 exponents. So 3 over 15 is 1 over 5. Y to the 5 minus 1 is y to the 4th. Sorry, 9 minus 3 is 6. Okay. I can also just write this as y to the 4th over 5x to the 6th. Remember, you don't need coefficients or exponents of 1. Alright, sorry for this longer video. This is the longest one in the whole unit, I promise. Alright, go ahead and work on your 1A.3 activity.